All right, today's lesson is on geometry again. We are going to talk about polygons today. Polygons. Has anybody ever heard of the word polygon before? What do you know about a polygon? Aiden? They do have sides. What else do we know about polygons? Aaron? It's not a polygon unless it's closed, a closed figure. Good. Oh, symmetrical? Polygons are not necessarily always symmetrical. Can you please put your pencils down and your eyes and your ears up to the front so I don't have to stop the lesson again? Thanks. Some do, but not all. Polygons are also flat. So, how do we name polygons? How do we name them? A polygon is a closed plane figure. So it's made up of lines, but those lines are hooked together. A plane figure is something that is flat, totally flat. So let's look around our room. What are some plane figures in this room? That means they can't have any depth or any dimension to them. So our tabletop is not a plane because it's about this thick. It's about 2 inches thick. The floor tiles, okay, they're flat. Good, that would be a plane. My poster, good. Will? The alphabet. What else would be plane figures? One more. Let's take one more example. Well, I think that there is a little bit of depth. You know what? Let's move on to my second question, which is which of these things in this room are not plane figures? Kaden? My smartboard, because it has some thickness to it. Sarah? Books are not plane figures. Aaron? Computer screens. Good. All right, moving on. A plane figure is a figure that lies in a plane, one that is flat, just like these, like road signs. You guys see them all the time. Okay, a globe, a cube, a pyramid. Those are all examples of things that are not plane figures. The difference between a closed figure and an open figure? Well, that means that the lines that are connected don't close. So you might see a shape that looks kind of like this. If it doesn't have a closing, that means it's not a plane figure. Now there are two types of polygons. There are regular polygons and irregular polygons. A regular polygon has all sides that are exactly equal. Also, all the angles are exactly equal. Which of these two signs do you think is a regular polygon? Dathan? The stop sign. Every side is exactly equal. If I took a ruler and measured them, they would be the same. Also, if I took a protractor to each corner, they would all measure the same. This one is called an irregular polygon because it does not have equal sides or it does not have equal angles. We know that because I can tell this is 90 degrees and this is 90 degrees. So they're right angles. But this one here, that's an obtuse angle. So it must be an irregular polygon. Can you think of other shapes that are regular polygons? Alan? Okay, what shape is that? Okay, a perfect square. I know I'm not a great drawer. That would be regular. Yeah. How about, I know I'm doing my best, Darius. How about this one? A rectangle. Is that a regular polygon? Why not? Because two sides are shorter. All the angles are the same, but nope, that would be irregular. What would be an Give me an example of one or the other, regular or irregular. Aiden. Okay, give me an example of a regular shape. Ooh, I'm going to do my best. I'm not great at this. Okay, Aiden says that shape is regular. Is it? Hold it. Right angle, right angle, right angle? Oh, this is irregular. Maybe there are, this is five-sided. But pentagons, okay, I know what you're thinking. Better?
Yeah, like that.
Okay. That one maybe, of course I didn't draw it perfectly, but that one might be a lot closer to a regular shape. I just don't have the options right now to draw that. Once we get to our smartboard screen, we can draw some that are regular. This is, let's name this regular, even though it's probably not perfectly. So, Natasha. What? Give me an example of an irregular shape. A triangle. Okay, like this. Sure, that's irregular. Is there such a thing as a triangle that would be regular? How would I draw one like that? It would need to... Okay. It would actually have to be what we consider an equilateral triangle. That means all three sides are equal, all three corners are equal. All right, you guys are doing great. Regular or irregular? America? Regular or irregular? Aaron? Why? Thank you. What is the name of this polygon? Kiara? Good work. How many sides did Molly draw if she drew an octagon? Alexis? Good work. How many hexagons do you see in that picture? Mm-hmm. Kin? Darius? Will? I think I only see one as well. Now I see some trapezoids. I can see a trapezoid here. Whoops. I can see a trapezoid down below. I can see one over to the left and over to the right. I can see some squares. I can see some triangles. Rectangle. I can see one of those. But I only see one hexagon. Good job. Which one of these is a pentagon? Sam? Okay, pentagons have 5 sides. Is that going to work? C is right. Which one has 6 sides? Brendan? Darn. He just said which one is a pentagon, and he said it was C. Did that have 6 sides? No, it had 5 sides. So let's go back to this question. Which is the shape that has 6 sides? Hex. H-E-X means 6. That's right. Okay, let's use some of our shapes here. Let's go with... There's a regular. There's a regular. Oops. Let's go with... There's a regular. Okay, how about Why is it regular? Why is it irregular?
Because it has one side longer.
Absolutely.
Yeah, that one's not right arrow.
Why is that irregular?
It doesn't have corners.
It doesn't have corners. That's right. Good job. Okay. Now I want to mention one other thing, and that is when you try to find the angles of a polygon, a four-sided figure, sometimes there's a missing angle, and I want to teach you how to find a missing angle. What if this one was 90, this one was 90, this one was 90? What would this one be? Okay, so if you added all of those up, the magic number is what? 360. So all four angles have to measure up, add up to 360. Now, this time I'm not going to draw a picture. Instead, I'm going to tell you my first angle was 81, my second angle was 101, and my third angle was 95. How would I find that fourth angle? Can somebody tell me a strategy that I could use to find the answer for that fourth angle? When I add them up, what do they have to equal? Yeah, so what could I do? Will says you could do what? From what? Keep going. 360 minus what? Just that one? Why'd you pick that one? Oh, you're on the right path, but you're not quite there. Dathan? Yeah. We could take all three of these away, and whatever we're left with will be our fourth angle. There's another way you could do that, other than Will's way. Darius? We could add up these three numbers and subtract from what? Brendan, did you hear what he said? To find the missing angle, Darius, tell him what to do again.
You add up all the numbers and then you subtract them from 360.
And whatever it is, you put it right here. And then you'll get your answer. Now, I would like us to try something like this. It's up to you which strategy you want to use, if you would like to add up all the angles and subtract from 360, or if you would like to start with 360 and subtract each one. Do you have a calculator up? Okay, go ahead. Don't shout out the answer. Let's go, Eileen. Squeeze and start from the beginning. Clear it and start over, Eileen. For those of you who have chosen to add up the numbers, once you get it, you can't forget it. You have to commit that to your memory because the calculator won't hold on to that number for you. Adding them up is not the answer. That's all you did, Eileen. You just added them up. That's not our missing angle. Now what do you do with that number? Go ahead. Okay, Cole, help me out. What'd you get?
I got 83.
83? Anybody get something different? Cole, did you add them all up and subtract from 360? Who started with 360 and subtracted each one? Aaron, did you still get the same answer? Good work. All right.